before we move to the next slide. Okay, let's get our pen back over here. All right, how about for endothermic reactions? Heat is a reactant or product for endothermic reactions. So last one was a product, so this one, these are just opposites of each other. So this one's a reactant. Heat is blank the surroundings. Is heat absorbed or released? Absorbed from the surroundings. Good. So when I think of endothermic, I think that energy is entering. Energy is entering the reaction. So the reaction should feel, if we're losing heat, then it should feel cold. Good. And then change in temperature will be negative, and our temperature, will it increase or decrease? Good, temperature will decrease. Very good. And for endothermic reactions, more bonds are broken than formed. That's something that we haven't talked about. We'll talk about it more on Monday. Okay, questions on this review slide? Okay, so now what we're going to do today is we're going to add this kind of graph. So this is called a reaction coordinate diagram. We're just tracking the progress of a reaction. So on our y-axis, we have energy. So down here, we have low energy. As we go up, we get higher in energy. And then down at the bottom, the x-axis is reaction progress. So this is, our reaction is progressing. And we looked a little bit at this when we talked about catalysts, but we're going to make sure that we really understand what's going on. So here we have our reactants. Our reactants have a certain amount of energy. And then we also have our products. So our products here are lower in energy than our reactants in this graph. Also, we have this part of the graph we talked about when we talked about catalysts. This is called our activation energy. This is the energy the reaction needs before it can start. So for a reactant to get to the product, we have to add this much energy to get over this barrier to get to our products. Okay, that's called our activation energy. This energy, this difference between our reactants and our products, is called our energy of our heat of reaction, okay, our enthalpy. We'll talk about this next time on Monday. But we're not going to focus so much on what the numbers mean today. We are going to talk about the shape of this graph, okay? So we have two ways of representing our reactions. We have endothermic and exothermic. So what do you notice about the endothermic and exothermic? What is different between these two? You see something? They're flipped. Perfect, yeah. So if we take an endothermic reaction and we flip it, then it becomes an exothermic reaction. That's true. And we can also see here, these are our reactants. So whatever comes first, that's our reactant. These are our products. In an endothermic reaction, the reactants are lower in energy than the products. Okay, that's when I draw an endothermic reaction, my reactants should be lower in energy than my products. When I draw an exothermic reaction, the product should be lower in energy than the reactants. Okay, so if on a bell quiz or a test I give you a picture, you should be able to tell if it's exothermic or endothermic. If it's endothermic, products will be higher. If it's exothermic, products will be lower in energy. Okay, let's practice that. So if I give you this picture, is this an exothermic or endothermic reaction? Good, this is exothermic. Products are lower, good. How about this one? Endo. Products are higher in energy, that's an endothermic reaction. So another way to think about this is an endothermic reaction, we have to put in a lot of energy before we can get to our product. So energy is going in to this reaction. And if we look at this one, we are getting energy out. We put in a little bit of energy, but then we get energy out at the end. That's exothermic. Okay, how about this one? We just care about reactants and products. Good, this is exo. Perfect. Good. So sometimes reactions have lots of intermediates. We don't care about those for exothermic, endothermic. We just care about where is the reactants, where are our products. Okay, now we need to review Le Chatelier's principle. So if we have this reaction and I tell you it's exothermic, and I increase the temperature, which direction will it shift? So it's exothermic, we're increasing the temperature. Is it going to shift to the products or the reactants?
It's added after reaction or before?
Yep, so that's what we have to know. So if it's exothermic, then energy is a product. Good. So if we add energy, so we have it at equilibrium, we add more energy, energy's over here, so it was balanced, we add more energy, so to rebalance, the reaction is going to shift back to the reactants, to the left. Good. Okay, how about this? If we have energy, or excuse me, if we have this exothermic reaction and we remove energy, so we cool this reaction down, which direction will it shift? Good, it's going to go the other way. It's going to go to the right. So we have energy or heat here. If we take away heat, it's going to look like this. So to rebalance, it's going to shift back to the products. Questions about that? Does that make sense? Okay. All right, one more example. So if this reaction is, we have this reaction here, it's endothermic. So if it's endothermic, what side of the equation does energy appear? Good, the left. So we have this plus heat. So if we heat up this reaction, which direction is it going to shift? So we have our balanced reaction, we increase the heat, it's going to shift away from that, it's going to shift to the right. Or to the products, either of those mean the same thing. Okay, if the temperature is decreased, so we have our reaction, we're going to decrease the temperature, which direction will it shift? Good, it's going to shift to the left. Okay, questions on this? Okay, I think that's our last slide. So I'm going to hand you out this assignment. It's a pretty short assignment. And we have 3 case examples. So I would like you to get into some groups and talk about this. I know our class is kind of small today. Well, as we look through here, so case 1 is we have some scenario. Plants use sunlight to combine water and oxygen to make sugars. So you need to decide, is this an endothermic or an exothermic reaction? And then explain why you think that. So use some evidence. Why would this be endo? Why would this be exo? Okay, depending on what you pick. And then, based on what you pick, what direction will the reaction shift if the temperature is increased? Is it going to shift to the left or to the right if you increase the temperature? And then you need to draw the reaction coordinate diagram. So I don't really care too much, I just need the shape. So if it's endothermic, the product should be higher than the reactants. If it's exothermic, the product should be lower in energy than the reactants. Okay? So for these 3 cases, you need to do all of those parts. Decide if it's endo or exo. Explain to me why you think that. And then which direction will the reaction shift if the temperature increase, and draw the correct reaction coordinate diagram. Questions on what we're doing? Hey. So I think this is helpful to talk with other people. So if you could get into groups, we've got just a few of us. Maybe get into groups of like 2 or 3 and talk about that and work together.